best practices, and Glenn Wadden will be our presenter for this session. So welcome, Glenn.
Why are we looking at best practices anyway? So the key is, why do you bother? Well, I go back to this idea of technical debt. If you don't get it right first, you're going to pay for it in the long term. So if you don't get your tag naming right, your database size right, you choose the wrong hardware, it's going to cost you in the long term. So a little bit of planning up front will save you a lot of heartburn in the longer period. Now, you can always go back and fix things, but it's easier if you get it right first time. Let's try to get it right. And it's hard to get it right first time. So take your best shot at it. These are the things that I think are important to look at. So procedures, tags, alarms, pages, navigations, performance, system monitoring, servers, hardware, and security. A lot of stuff to look at, but there are things that apply to most systems, but not necessarily all systems. So let's just walk through them all to see what is the most important. Now, Devraj did a session on procedures about getting it right, the software development life cycle. We have a very elaborate software development life cycle. This is one little piece of it shown in the diagram. So I mentioned technical debt. It's the idea that if you don't get it right first time, you're going to pay for that. There's a debt to be earned or paid back. The longer you wait, the higher the interest is on that. So if you choose the wrong product, you choose the wrong architecture, you try to cut corners, eventually it's going to catch up to you. And you can let it go until it really starts to bite at the end. So things that today's Glenn does as a shortcut, future Glenn is going to pay for. I've learned that one over the last 38 years. It's easy when you start, you just write code. Then you find out, no, that was a bad idea. I should have had more documentation. I should have had a better plan. Should have thought about it longer. We've learned over the years that it takes a lot of planning. What you're doing is not the same as developing a software product. So you can kind of scale things down, but I don't want to over-scare you, but planning is an important part of any big project. And almost everything you do is a big project, and everything you do is mission critical. There's nothing you do that doesn't matter. Documentation is a good thing. One of the tips I have is you take the documentation, you add it to the VT-SCADA directory, whether it's PLC programs, PDF files, manuals, and you add them to the documentation folder, or just add them to a folder in VT-SCADA, hit import file changes. They become part of the repository. You can update them later, but when you put them in the repository, they become part of your change set. They get distributed to all your machines. Suddenly you've got all your documents on all your machines. Good tip. It's always good to take advantage of the questionable status. Don't know if you guys use that at all, but it's a good way to start looking at a new system, especially you put some tags online, they get marked as questionable. A little question mark appears next to your tag or your widget on the screen. It's a really important tool to say, I haven't checked this one out yet. So you can, as you go through and verify that that tag is showing the right value for that tag. We've had systems that we've upgraded from old applications that the value that they thought they saw on the screen had for about 20 years been showing the wrong value. It's been showing a different tank level than what they thought it was. So it's always good to make sure. Obviously, it wasn't that important because they never noticed. But nevertheless, the question auto-deploy. I'm sure if you're familiar with the repository, there's a switch that by default turns to auto-deploy, which means that any change you make on one machine gets automatically pushed to all other machines. That's the default behavior. It used to be the other way around, though. You didn't push stuff out to the other machines. What we found is people forgot to hit the deploy button. So it'd be running on one machine, it's all working. Next backup server doesn't know anything about it, and they're wondering why is it not working. So the question is, which way? So the pros and cons are, if you put it auto-deploy, you know that things are going to go out right away. The bad part of auto-deploying is that if you get it wrong, it's suddenly everywhere. So you've got to get that balance between, okay, I've got a discipline here, I can check it out on this one machine, And then when it's good, I hit deploy, and all the operators get it. So the problem is you forget to deploy. And you have to get into a version upgrade policy. I mean VT SCADA versions. We put out a incremental version every couple of weeks. Now, it's always good practice to look at the changes log, see if there's anything there that you might be wanting or needing. But some customers get in the habit of upgrading every couple of weeks. That's quite a hassle sometimes. There's some big systems that it takes a day to upgrade the system. If you're doing that every 2 weeks, that's a real hit. There isn't really enough incrementally on a 2-week incremental build that you generally want to upgrade. So think about how you want to upgrade. Think about, oh, there's a feature that I need. I'm going to do it every 3 months or something of that sort. Look at things. Oh, there's a bug I noticed there that's been bothering us. I'll get that build and upgrade. So think about it as a policy. This one's hard. This is what we do very consciously. Review each other's work. So I have a policy that there's at least 2 pair of eyes on every piece of work that goes in. And that seems like a lot of work, but you'd be surprised how perfectly tested code is wrong half the time. If you try to get it in there, you do it well, and you give it to, I can write something, and I give it to a new guy that's only been around for a month, and he finds a problem with it. So you could actually get a lot. And I don't mind people finding a fault with my code. I'm happy that they found the problem before it went out the door. So you got to get out of the idea that someone reviewing your code is a bad thing or reviewing your work is a bad thing. It's a good thing that someone's going to find a problem. And the one other good thing about reviewing each other's work, we call it validation, but that reviewing each other's work, the new guy reviewing the work learns from me what I've done. So he's learning from me, not only fixing or just identifying problems, so he'll test it in ways that seem stupid to me, because why would you use it that way? Well, he used it in a way that was legitimate but stupid, but found a problem. Okay, good. Thank you for that. So it's a way to share knowledge between people. So if you have a junior person and it's reviewed by a experienced person, the experienced person can pass on tips back to the junior person. This is like, look at all my work. Works the other way too. This is our flow chart for a new feature, and I don't expect you to read that. I think step 21 is where you start writing code. This gives you an idea of what it's all about. Getting a process right is really important. It seems incredibly tedious, but some of these steps go by very quickly, but you're checking for security, you're checking that the documentation is done right, you're doing all these things, and it's really important. So let's get past that process stuff, looking at tags which are more to the point of day-to-day stuff. You got to get a naming standard. So we've got the sibling tag thing coming in now. It makes it easier to organize your tags. You have options now that you didn't have before. So the naming standard is fairly important, but not absolutely critical, because you can actually change the names later. But it's a whole lot easier to get the names right than decide after you've created 1,000. Wouldn't it have been better if we called them in this order and reorganized them that way? You can do that later, but having to redo 1,000 tags is just pain. We've had people do that, and VT SCADA does allow you to change the names, reorganize your tag trees without losing any history or page configuration, but it's better to get it right from the beginning. So it's a structure, how your contexts are laid out, what is a good name, calling something on one side that's called centrifugal pump, and over there it's called pump. You have some sort of consistency across your application, so it makes it easier to, I want to find all the pumps, you just search for pump rather than whatever it might be. Sibling tank feature, useful. The equipment type, I don't know if you use that. Take advantage of it. There's a parameter in the IO tags called equipment type. By default, pump is the only type that we deliver with the product, but you can do pH meters or flow meters or pressure transducers, anything at all, temperature, The idea is that you put a equipment type on the I/O, and that allows you, one, to find all these devices in your system using the tag browser. So you can go to the tag browser, filter by equipment type. If I want to find all my pH meters, I just go pH meters, there they are. Also, there's a style tag. I don't know if you've taken advantage of that. The style tag allows you to specify colors for each on-off or each type of equipment. So each different type of equipment can have its own color scheme. So that if you assign the pH meters, use this color scheme, pumps use that color scheme, and then you can change them in one place. So it's a pretty neat feature. And if you don't use it right away, it's okay. You've got them all set up from the beginning, rather than again going back and having to set up 1,000 equipment types and tags that already exist. So context tags are a great tool. You probably use these already. So probably not going to educate you too much on this one, but the idea of creating a context tag allows you to organize your tags into a folder effectively, that where you have the yeast plant or digester or something of that sort, where you have the tree of tags organized by a logical scenario like you would in your file system. Yes, names and structure can be changed. Easy if you get it right first. There's another thing on tags. There's a start tag condition on tags. This is a useful thing if you have sub-areas of the plant or the utility where you want to actually run a smaller subset of tags on one machine than on another. So the start tag conditional, if the workstation name is this, don't start this driver and all these tags, or this context is not useful to this machine. Allows you to use a lower capacity computer, allows you to use a lower tag count on that machine. So it's a useful tool. And you can you can set it to a setting so that, in this machine I want to turn on these groups of tags. Tag templates also very useful. I've heard people in courses that say, "Oh, I wish I had known that 3 months ago," because I built hundreds of tags by copying and pasting these trees one at a time, modifying them all. And if they had a template, I would have one place to set it, and they'd all change. Well, now when I have to change, I have to go change all 100 copies of this thing. So this is a really, think about it before you get there. We have the template set up with what I would call a design by example. The idea is you create one tag tree, one context with all the tags underneath it. That actually works. And then you can hit an option to create tag type from that. So you have this one. Once it all works, let's say that one's going to be my template. Everything else after that will be essentially an instance of that. So you change the template in the future, everything else just follows. Now, since you do this templating thing and you've templated one, it's best just to keep a copy in a separate folder somewhere. As you create a context, maybe you call it templates. You put the master template in a separate folder. Because now any of these template instances, if you change one and say update, it's going to change all the others. But if you put it in the context, you have this base one that you don't modify. And then you can add or modify any individual one to override parameters for a particular instance. But you don't want to make that one the sort of the generic one. So if you have the templates clean, and then you can disable them, so you don't actually eat up any of your I/O tags. So you disable all your templates in this template folder. Pretty useful trick. I think I'm stealing this from Keith's tips and tricks one. So alarms, so I say what it's really all about. Alarms are what it's really all about in my mind. What's on the page doesn't really matter as much as the alarms. It's not really that anybody sits in front of the computer like they're flying a plane, like a pilot. They are walking about doing their work, and the alarms are what draw their attention to what's going on. You see lots of systems, we run into them where literally have 500 graphic pages. You can't look at all the pages. You can't scroll through them all, see what's going on. So what you have to do is rely on your alarm system. The alarm system is what it's all about. And you got to get your alarms right. So the alarm system, you have to get meaningful descriptions on your alarm. If you said something like pump overload, which pump? I have 600 pumps. Which one is that went wrong? And another thing, operators get fatigued with alarms. If they start to see more than about 200 a day, they just zone out. Can't deal with it. It's too much happening. I go to the bathroom and suddenly like, oh, another 10 alarms. Acknowledge them all. You need to get the alarms down to meaningful things. So it needs to get down to less than 200 a day. So that means things that are nuisances need to be made an event or something that's not really critical to draw someone's attention to. Or you have to split your system into different zones so that this zone is handled by one person, that zone is handled by another person, so that they are not overloaded. So you have to set your priorities based upon the severity of the consequences and the time before that consequence kicks in. So you take a look at critical means that if I don't do something soon, something really bad is going to happen. So there's a chlorine gas leak. I better do something pretty soon. That's critical. And you get another one which might be, the lake level is high. Well, in a few days that could be a problem. So that's possibly a low. So you have time, and the consequences may not be bad. However, if there's a dam that's going to overflow, maybe that's more important. So you got to look at that matrix of consequence versus time you have to react. If you've got hours or days to react, it's a lower priority. If the severity of you not dealing with it is low, then yeah, it's okay. Severity, someone's going to die, that's high. Take advantage of alarm suppression. This is an important feature for looking at alarms, because you get these alarms that someone goes in and turns the power off on a panel. And all of a sudden, you get 20 alarms because the power's off. So that's not a useful piece of information for the operator. The operator has to recognize, these are all coming, I bet you somebody turned the power off. You don't have to put that burden on the operator to figure that out. It would be much better to say there's a power off problem. And the way you handle the extra nuisance alarms is that you put a suppression or a conditional on the alarms that are consequent. So let's take a look at one of my favorites is a low flow alarm. You can put a low flow alarm in, but if the pump is off, that low flow alarm is not, that's a nuisance. Of course there's a low flow, the pump is off. So the low flow alarm should only be working when the pump is on. So you make those alarms, that consequential alarm, conditional so you don't get these nuisance alarms that every time the pump turns off, I get a low flow alarm. Of course there's a low flow, there's no pump running. Get that 200 a day down. Shelving is a really powerful tool in VT SCADA that you can go to the alarm page, pick an alarm or an area, and shelve the alarm. Shelving means that you take it out of service, but only for a limited period of time. So the kind of thing you do is someone's doing maintenance on a piece of equipment. So again, rather than having issues with someone, they're testing meters and they're timing them from low range to high range to see if they're all calibrated right. You don't want those things to generate alarms. So you can shelve those alarms while someone's working on it. And shelving can be done, typically you do a shelve for a specific period of time. When you shelve something, you say, I want to shelve for 2 hours. So that if you forget it, automatically turns back on again. So often people are doing maintenance on a particular site. You want to say, yeah, this week they're going to do maintenance on that site, it's down. I'll put a 5-day shelve on that alarm. And you can turn it on again anytime as long as you remember to. Got to find the bad actors. I've seen systems where you go in and you see, what are the bad actor alarms? There's a report in the alarm page that shows you the bad actors. Those are the ones that are coming on an awful lot. And if they're buried in among the other 100 alarms that you're getting a day, it may not be that obvious which ones are coming on frequently. Some of the operators might start to recognize them and say, oh, that's that one again. Okay, so we won't even worry about that one. But you got to find those alarms to stop that operator from seeing things. I've seen sites where, oh yeah, that turbidity sensor always gives us problems. It goes off 5 times a day. Let's just kind of ignore that one. It just comes, you just kind of start to ignore it. So you got to fix those bad actors, either by fixing your sensor or just turn it off. Organizing your pages, pretty simple stuff. You got to put them in a hierarchy. So it's not uncommon to have dozens to hundreds of pages in an application. So the best structure is you have a top view. So you have overview pages that are really showing your key performance indicators and the status of each subordinate area. So if you can imagine, like have East Plant, West Plant, South Plant, North Plant kind of on your system, you can show total flows and just the status, is everything okay there? And then you click on any one of those, it'll take you down one more level. Get more details on that North Plant. See what's going on there. You get, you might see another 20 parameters there that are more interesting in that level. And then you go down and say, oh, here's my filters. I need to see how the backwash is going. But by the time you get down to the third level, those are the details that you might have hundreds of pages showing you the details. But the top level, you just want to know, is everything green? Because you can't look at all those lower pages all the time. But you need to be able to navigate to them when there is a problem. So when you click that Go to Alarm page on your alarm, you get the alarm page, and when you click on Go to Page, you can go right directly to the page where that alarm is shown and get more details about what's all the stuff around that. Is the temperature right? Is the flow right? Is the pressure right? In BT-SCADA, you can hook up any number of monitors that Windows will support, so consider using 3 monitors. Have an alarm page, an overview, and details. As I said this morning, you only have so many clicks in your life. If they're all up on the screen at once, it'll save you a lot of clicks and extend your life by years. Performance. This is one I've seen a lot of, especially in Modbus. It's not strictly to Modbus, but people don't put their I/O in consecutive registers in Modbus. They tend to sometimes just sort of scatter them all over the memory map. Every time they're in a different place in the memory map, it's a separate read out to the device. And if you're going over a cellular connection or a serial connection, even worse, every block requires a separate communication packet going out to it. So it takes a long time to get your updates. If they're all in one block, it goes much faster. Another related kind of problem is that although they may be putting them in the same block, they may say, I want to read these at 5 seconds, and I'll read these once a minute. Every time you put a different timing for each piece of it, it takes, I got to read the 1 minute once every minute, and every 5 seconds, and they're all kind of mixed together. It's just as bad as having them fragmented. So try to keep the polling rates consistent across consecutive registers, if you can. It makes a huge difference to what the performance of the communication is. And it's not us, it's really the PLC and the communication link that's the bottleneck. You can optimize that by getting things kind of grouped together nicely. Yes, and reduce the polling rate to the slowest acceptable. Everybody says once a second. Do you really need to see the tank level every second? It's not moving that fast, but you still have to poll it. And if you get 10,000 tags that you're getting once a second, that's putting a big demand on the system, eating up your disk space, logging any minute changes that happen. It's a, can we get away with 5 seconds? 5 seconds is pretty good. That's 5 times faster, or 5 times more capacity you have in your system. Dead banding is really important too, because every time a value comes in, it checks it against the last value and see, has it changed by this dead band or not? And you use that because on analog values, particularly, there's always some sort of instrument noise that comes in, and that instrument noise, if you have your dead band set to 0, every little change, which is totally insignificant, gets updated in the system, gets communicated across to all the other BT-SCADA servers. And then the historian dead banding is another step on top of that. It will get logged to the hard disk drive, and you will end up eating up all your disk space. And a year from now, you'll say, "Oh, what happened to my disk? I ran out of disk space." So get your dead bands to be something useful, like 1/10%. What can you tolerate? Something fairly tight, but it makes a big difference in how much data moves on. So if you take something that's really small, say, how good are your instruments? Rarely do you find an instrument that's better than 1/10% accurate. But there's always noise on the line. So digital values, not a real problem. They're on or off. And you want to record every single one of them. They change so rarely that it's not a dead banding issue at all. This one is really it's not just a startup, but this have the idea expressions for tag parameters. Sometimes they're really, really useful, but don't get too attached to them and sprinkle them around like salt on your food. Because every time you put an expression in a tag parameter, it slows down the startup of the system. It has to evaluate, run some expression to try to figure out what that should be. There are lots of great cases where that's useful, but don't use them if you don't need to. But adding tag expressions to parameters, great, but you can see it can add, it can multiply your startup time by some significant multiple. You took a system that might run up in 2 minutes and suddenly it's 10. And avoid unchecking the optimized tag expressions. Yeah. That will, again, slow you down at runtime. So this one will reevaluate the expression every time something changes in that expression. It also takes up more memory to keep that thing monitored. So considering adding extra servers to share the load, one of the ways you do that is you split some of the drivers over one machine, other over another. One trick that you can use, don't see it very often, but you certainly can take one PLC and you can create 2 VT-SCADA drivers for that. It seems odd, but you can. And you split half the tags in one driver, half the tags in the other. And then you say, that driver's going to run on this machine, that driver's going to run on that machine. And you've basically split the load into 2 different machines without ever having to add another PLC. And of course you have them fail over so that one of them dies, the other one takes over the full load. System monitoring. This is one that we see people getting bitten by a lot. Don't let problems sneak up on you. Watch for disk space. You can put the workstation status driver as a tag in VT-SCADA that will measure things like disk space, CPU, and memory. And you can put alarms on that. So if your disk space goes too low, you can watch it and say, oh, that shouldn't be this low. Or I better buy another disk space, another hard drive, because if you run out of disk space, you're down on that machine. Driver quality is another little hidden one. There's a value in the drivers that indicate essentially the percentage communication quality. So 100% means no issues. Every packet going out is coming back. If you're working on a less reliable channel, typically like a VHF radio, less of those nowadays, 95% is probably okay. That's typical. They fail a lot. Birds fly by, the wind blows, car drives by. But if you don't get it, if you don't notice it, the retries on the driver will recover from that. They'll heal it. So I do two retries on my system and it keeps going, but it's getting worse and worse and worse. I just don't see it until it starts to fail. So if you watch the driver quality again, you can put an alarm on it. If this thing goes below 95%, 98%, whatever your quality level is, then you can say an alarm, I'm still getting data, but the tree is growing taller. Services page, great tool for watching over what's happening with your RPC, your communications between BT SCADA to BT SCADA. So this is a good tool. Have it available, keep it at your fingertips. It's a good thing for the IT-ish people to watch over, is everything what it should be? And we have the historian status widgets. Historian status widget gives you indication of how much historian data is being written to the drive, and if there's any backlog of data going to the drive. So you can look at that and say, I never realized that we're writing like 60 kilobytes a second going out to the drive. Seems like a little bit. Let me do my math. Ooh, that's not looking good. I'm going to run out of disk space in a week. There's also the modem status widget, and I feel sad for you if you have to use modems, but it's a good tool to keep track of what's going on with your modems. We're one of the, I think, perhaps the last company that's actually using modems. And we have to support them because they're really important, but they're awful.
When you try your HDMI cable, it's cutting out every now and then.
Yeah, I know. It seems to be tight.
Okay.
I think the other guys are having trouble with that too. Servers. Have at least two. We've had customers come in on, one of the customers in Florida were called us one week and said, oh, we had a competitor's system. We had one server running, no backup. It got hit and it's down and not recoverable. Help. Never run on one machine, never run without a backup. Obviously, if you have two servers running, you're always going to have a hot backup. Some of the worst cases I've seen is one of the East Coast cities here had a lightning strike that went through the Ethernet cable and took out all but one of the BT SCADA systems on the network. Good news is that there was one left, and they could recover from that one, get everything back, all the history, all the configuration, and everything. So, yeah. If you have a lot of drivers, City of Houston has, I think, something like 120 Allen Bradley PLCs. The normal way you set up drivers is for every PLC tag, you have a server list. And if you imagine having to set up 120 of them, that could be pretty tedious. Well, they have to set up and configure 120 drivers. It's a huge plant. But there's a better way. There's a parameter there that allows you to specify the driver list. So you can group a set of drivers into one server list so that you can say that this group of drivers or PLCs is going to run on one server, this group is going to run on another one, this one's going to run on the third one, this group is going to run on the fourth one. And you can organize your server list such that if this one fails, all of its PLCs will get divided among the other three so that you can nicely load share, but you only have four lists to set up rather than 120. So this is what I mentioned before. You can actually split make multiple drivers on the same PLC. so that you can load share across 2 different or 3 different servers. Now, when you start to get really big, it's always worthwhile considering putting 2 historian servers online. Take all the historian work off the main I/O servers. Where the load goes in any VT SCADA application is on the I/O servers. Those are the ones that are actually communicating with the PLC. Those are the ones that take the most CPU load. So if you can divide the load among those, and then you can offload historians to another machine or 2, that will make a notable difference to your performance. This is now getting into big systems. I say big systems, 50,000 tags and more. Client of client. This is a little bit of a deeper topic, but it's not too crazy that you'll have multiple facilities across a district. And you'll have multiple machines in each of different east and west, perhaps. Now, the normal way you would set up is that all machines would point to one server for I/O for machine or PLC A. So you have this, say, low bandwidth connection between the 2s. A diagram would help here. So that when the 5 machines on the receiving side, we'll call it the west side, have to go to the east side to get the data for that PLC A. There's a different way to organize your system, so you get 5 times the data going through this poor connection. You can designate one of the machines on the, I forgot my east and west, on the receiving side as being a client to the main server, and the other 4 will refer to that intermediate one on the client side. So the data only goes across the thin, poor connection once. And then the other 4 at that receiving site will get their data from that intervening machine. We call that a client of client architecture. Drivers will do that, and it makes a lot more sense. We do have some funny or unusual systems where we have a server here in Florida and another one in Nova Scotia, and you kind of funnel data through, and you want to have a client of client kind of arrangement to say, okay, we really want data to only go once, not 5 times across that connection. All right, next one, security. Getting close to my time, but this is fine. There's this product called Shodan on the internet. You can run it, I ran it. That's what I ran. These are the top ports that are running VT SCADA. This thing will tell you every machine in the world that is running VT SCADA on what port. Okay, the top one, 400, or on port 443, there are 218 computers on the internet running VT SCADA on port 443. This is a great tool if you're a hacker. 443 is the secure one. The next one down is the scary one because port 80 is generally not. There's 131 computers out there on the internet that are running unsecured VT SCADA. That means anybody on the internet that has access to that path between the source, the legitimate customer and server, typically at each end, so it'll probably be in the building that's someone's logging on or the building where VT SCADA is located, could snoop on that, see what the username and password is. It's really a bad idea. Anybody can find them out. It's not just a number. You can find out what the IP addresses are. I know we look at these and contact customers, and they say, no, I'm okay. Some of them are good, and they say, no, but some of them that we contacted a decade ago are still running open, unsecured systems. Anyway, just to scare you a little bit, it's really easy to find it if you're not. You think you're just being obscure and you got an IP address. This thing scans every port in every machine that's out there all the time. So there's ransomware and cyber warfare. Ransomware is pretty bad. They'll lock up all your machine and put up a ransom based on how big you are, how much they think they can get away with. They say, well, you've got to pay me $500,000 if you want your system back. We've had some positive stories that one system was on the internet, the backup server wasn't. It's just talking through VT-SCADA's RPC port. The one that was on the internet got corrupted, shut down, basically. The backup server runs fine. So they just kind of reformat the main one, do get from server, everything's back up and running. So that's a good story. But there are worse. The cyber warfare ones are, they don't want money, they just want to shut you down. And those are cities, not city-states, but more nations that are deliberately trying to attack critical infrastructure at an opportune time. It's bad. So they've got an eye on where all the critical assets are, power plants, water systems. They know where you are. They may not be able to get in yet, but they're watching. So don't let them wait. Don't let them in. Make sure you get it right. We have a security guidelines manual, and we have a session coming up on that to kind of walk through that. Andrew Green's doing that. Do you see where that is? Friday at 9:30, we're going through the VT-SCADA security guidelines manual. That's something that's shipped with VT-SCADA. Tells you how to secure your system beyond what is in VT-SCADA. All of the infrastructure around it, the networking and so on. What are best practices? One of the best practices is don't share your usernames. They do that a lot in a lot of utilities. We'll just have operator 1234. Bad idea, because when operator 1234 leaves, he is still, there are some notable cases like Oldsmere here in Florida that had problems with that sort of thing. Someone logged in that had been a former or an SI that had access to the system. Delete usernames immediately. If somebody's out at the door, shut them off. I've had systems like, problems like that in other jurisdictions as well. Australia, I think, had some notable cases. Two-factor authentication, you can turn it on now, use it. It keeps anyone that happens to discover or guess your password from even getting in if you have two-factor authentication. Make use of roles. That means that you don't just assign individual user privileges to a person unless you really need to. You have a role that says, this guy's a level 2 operator, he's a level 1 operator. That means he has these privileges, and then the next guy comes in and says, oh, he's a level 2 as well, so you just give him a level 2 and you don't have to guess. And you make changes in one place is the right place. And use Active Directory integration. This means that you use the Windows security that you use to log on to your laptop or your computer is what connected to VT-SCADA. What it means is that the IT people, when they shut you out of an account on the network, it shuts you out of VT-SCADA as well. And when you're doing, a lot of people do a VIC server in a DMZ, which is like an isolated piece of the network. Good idea, but what you should put in there is a run-only server, which means you turn on a switch. That means you can't do control from that machine. No matter, even if someone has privileges to do control, you don't let them do it. Just in case it gets hacked, no one has control. They may be able to see your information, but they don't have the ability to do something. And of course, using security. I think instead of allowing these port 443s on the internet, it's probably better to enforce a VPN connection into the network and then use a secondary connection from that point into VT-SCADA. You block them as a firewall level. And even better, less convenient, don't let the industrial control system talk to the internet at all. That may be not practical, but people can get away with it. USB keys are becoming infamous for transferring viruses. So there's been a rash of viruses that have been spread by people dropping USB keys in parking lots. or on, you know, on a table in the food court in a shopping mall. People will plug it into the laptop to see what's on it. Well, what's on it is a virus, and you may not know it. And if you can have physical access secure, even better. So, you know, there's very few places that you can walk off the street and get at the control room, but it's always good to make sure that you don't have the ability for someone to walk in the front door, walk down the hall, and go into the control room. Hardware. Think about engineering workstations versus servers. So people are often thinking that I need a good server, and servers are designed to run a lot of web pages at the same time. So they have a lot of cores that run at slow speed. We want an engineering workstation. We want something that runs this task really fast. Tend to be cheaper too. High clock speed versus more cores. That's what you're really after. Get the latest generation processors. Aside from clock speed, the newer processors that are out there are more powerful. They can run faster for the same clock speed. So if you have a 5 gigahertz clock on a 15th generation Intel, it'll run so much faster than a 12th generation Intel for the same clock speed. So it's not just that. And an i7 runs much faster than an i5 for the same clock speed. So it does matter what you buy. i9, i7 are very similar. Yeah, get 16 gigabytes of RAM. RAM's almost cheap right now. 32 is not bad, 64 is okay. SSDs, absolutely. It's hard to buy a machine now without a solid state drive. They're so much faster. Get your machine up and running faster, get your history faster. RAID drives, not necessary. You can use them, but they're not necessary. We already have redundancy across the network. So we have backup PCs, backup VT-SCADA backup VT-SCADA machines, which are replicating all your history and all your configuration in real time. And I've seen some really bad cases where we've used sort of server type machines that don't have a separate memory card, graphics card. Motherboard cards can be absolutely pitiful for performance. You wouldn't think it would make any difference because I'm not displaying a lot of graphics or videos or anything of that sort, but it can spend a lot of time just drawing little numbers and squares on the screen. So go with a separate graphics card. So, thank you.